Today we will go over the converse of the Pythagorean theorem. Before I tell you what that is, first let's look at this question. Can we form a triangle with side lengths 6, 9, and 7? So this is a bit of a review of the triangle inequality theorem. To do that, we check to see, are the two smaller sides, 6 and 7, when I add these together, is it greater than the third side, the biggest side, which is 9? So we see 6 plus 7 is 13. We have 9 on the other side. My two smaller sides when combined is greater than the third side. So yes, it can form a triangle. So the converse of the Pythagorean theorem has something to do with forming triangles and looking at the sides of a triangle. Pythagorean theorem tells us that if a triangle is a right triangle with side lengths ABC, and C is the hypotenuse, then we have this equation of a squared plus b squared equals c squared. So if we have a right triangle, then a squared plus b squared equals c squared is the equation we use. So the converse going backwards, if a squared plus b squared equals c squared in a triangle, then it has to be a right triangle. More specifically, we can actually identify if a triangle is right, acute, or obtuse given three side lengths. Here we go. Let me zoom into the section. Alright. So if a squared plus b squared is greater than c squared, then we have an acute triangle. If a squared plus b squared equals c squared, that's the Pythagorean theorem, then we have a right triangle. And last, if a squared plus b squared is less than c squared, then we have an obtuse triangle. So let's practice that with some of these numbers over here. Example 1. First, you still have to check. Before you jump straight into these three equations, check. Can we make a triangle in the first place? So let's try that. We're checking. Is 6 plus 8 greater than 10? We know 14 is greater than 10. That works out. So yes, we have a triangle. So let's use our equation. A squared plus b squared and compare it with c squared. We know 10 is c squared because c is the biggest number. A and b, we don't really care which one's a, which one's b. We can switch a and b around as long as 10 stays as c. It's the biggest number. Alright, here we go. We have 36 plus 64, which is 100. Comparing that with 100, 36 plus 64 is 100. So a squared plus b squared is 100. C squared is also 100. They are equal to each other. That means we have a right triangle. Next up over here, again let's check. Is 10 plus 20 greater than 25. 10 plus 20 is 30, which is bigger than 25. So yes, this is a triangle. So now we can use our equation, 10 squared plus 20 squared, and compare that with 25 squared. Now I will show you how to type these in a calculator so that we can skip a few computational steps. The left side, a squared plus b squared, you can type all in one line on the calculator right here. So that tells me that's 500. And we are comparing that with 25 squared, 625. So in this case, c squared is greater than a squared plus b squared, which according to our rules makes it obtuse. Last bit. Now some get confused because they can't identify what's the biggest side. Even though all the numbers are the same, the smallest number is a 3, the middle number is a 3, the biggest number is a 3. Think of it that way. So we're still checking, is 3 plus 3 bigger than 3? Sure is. 6 is bigger than 3, greater than 3. So let's go ahead and set up my equation, 3 squared plus 3 squared, and check, compare that with 3 squared. So 18 and 9, comparing, 18 is greater than 9. So according to my equations up here, that makes it a cube. And last example, 3, 5, and 9. And here's why checking is so important. Many times I see students jumping straight into this. They identify 9 as C, so they go and check 3 squared plus 5 squared, comparing with 9 squared. We have 9 plus 25, which gets me 34, comparing with 81. They see 81 is bigger, and therefore conclude this is obtuse. This right here is wrong. Because first we need to check if we have a triangle. Check first. 3 plus 5 compared with 9, is it greater than 9? We get 8. Is 8 greater than 9? No, it's not. So this is not a triangle. So right off the bat, can it be obtuse? If it's not a triangle, then no. So please always check, can you make a triangle first? If we can, then go ahead and check. Do we have an acute triangle, a right triangle, or an obtuse triangle?